Good morning, guys. Today's the last day, day 3 of the chain rule. I broke this into 3 days because it's very much rule that is messed up a lot, and it's a big deal with finding derivatives. So today we're going to look at a couple multiple chains, and all a multiple chain is a function inside a function inside another function. So in function form, I'm kind of looking at something like I said yesterday, f of g of x. So I'm going to say f of g of h of x, close, close, close. So I have actually 3 functions. I have a function put inside a function, and the combination of those 2 are inside the third function, like I have here in number 12. Now, what I'm going to do, so you can see all 3 of these, is I'm going to write it how most people would like to see this written, and I'm going to say a cube. So in this case, okay, I'm looking at, here's my function f, here's my function g, and here's my function h, okay? And when I'm doing a multiple chain rule, I'm doing the same thing as I did with the regular chain rule. Regular chain rule is f of g of x, right? And when I find that derivative, what I did was I took the derivative of the outside and I left the inside of it times the derivative of the inside function, okay? Well, in a multiple chain, this chain can just, there can be more than 3. So what I'm going to do, symbolically, is I'm going to take the derivative of the outside function, f prime, and I'm going to leave g of h of x inside it untouched. Then I'm going to move to the next function inside. I'm going to take the derivative of g. Okay, so I'm going to have g prime, and I'm going to leave h inside of it. And then I'm going to say times, better not do that, I'm going to go fuchsia, times the derivative of the inside one then, which is h prime of x. So basically, all I'm doing is I'm moving from my outermost function, and I'm taking the derivative of the outermost function, I'm leaving the inside function there, or the inside functions, plural there, and then I write them, and then I take the derivative of the next one that's inside, leaving the next one inside, and so forth. So basically, my y prime, I'm going to try to color code this here, except I'm going to go blue because I'm starting blue. So I'm going to say y prime is going to equal 3 cosine 2x minus 7, and then I'm going to drop the power. There, I just took the derivative of the outermost function. Okay, so that was this function I just took the derivative of. Next, what I'm going to do is I'm going to take the derivative of the next function inside. Okay, and the derivative of cosine is negative sine, and that leaves h of x in there yet. And then I'm going to say, I should say times, and then I'm going to say times the derivative of my innermost function, 2x minus 7, which is going to be times 2. Then what I need to do is I just need to come back and clean things up. Well, I'm going to look at a 3 times a negative 1 times a 2. So y prime is actually going to be negative 6 times the cosine squared of 2x minus 7 times the sine of 2x minus 7. And that would be my multiple chain derivative of number 12. Okay? So what I'm going to do is I'm going to come here. We just have a couple examples. And what I would highly encourage you to do is hit pause and try these on your own. What I'm going to do is I see this as a multiple chain. This is going to be y equals, and I can see my sine of 3x squared minus 5. That is to the 4th power. So I'm going to say y prime equals the derivative of my outermost function. That's going to be 4 times sine 3x squared minus 5. And that whole sine function is now going to be cubed. Then I'm going to move to my next inside function, and that's going to be times, derivative of sine is cosine of the h of x function left inside of it. And then that's going to be times by my innermost function, which is going to be 6x. Then what am I going to do? I'm going to clean everything up, okay? And it's 4 times this quantity to the third times the cosine times 6x. So I can kind of see 4 times 6x. Well, my derivative simplified is going to be 24x times the sine cubed of 3x squared minus 5 times the cosine of 3x squared minus 5. And that would be my derivative. Notice I have all kinds of composition functions left inside of there, okay? And then we're going to come to another example here. Again, I recommend you hit pause, you try it. But the key is to see it as you want to see it. Secant 3x, and the secant is what's squared. So then I'm going to take the derivative of my outermost function first, y prime. Well, that's 2. Derivative of secant is going to, I don't take the derivative of secant yet. That's secant 3x. And then I'm going to drop that power to 1. Then I'm going to go to my next innermost function. That's secant 3x. Well, the derivative of secant 3x, that's times secant 3x times a tangent 3x, because derivative of secant is secant tangent, times by my innermost function of 3x, which is going to be times by a 3. And as I look at this, really, I'm going to have a y prime equals, and I got a 2 times a 3, so I can call that 6. Now notice this next one is times a secant to the first power 3x times another secant to the 3x times another tangent 3x. And most of you said, hey, Kruger, why aren't you putting these two together because there's 2 secants? Well, you're right. It is. The actual answer would be y prime equals 6. When I put everything together, it's going to be a secant squared 3x times a tangent 3x. And that would be my derivative of what secant squared 3x is. Okay? And through that whole process, it's just what happens. And when I put my like terms together and I multiply a secant times a secant, I do get a secant squared. Okay? So what happens next is we're going to integrate the product rule with the chain rule, and we want to write our answer as a product, which means we're not going to want to distribute. Remember, the whole point of taking a derivative is to find flats, okay? So this is like my u, this is like my v. So I'm going to say my derivative is the derivative of my first term. That's an easy one. That's going to be 4x to the third. That's going to be multiplied by the second term, which is 5x plus 2 cubed, plus the derivative of my second term. Now my second term, okay, that's a chain rule. That's going to be a 3 times 5x plus 2. I got to drop my power to a 2, times the derivative of my inside, so that's going to be times by a 5 yet. And then it's going to be times by the first term, which is x to the fourth. Now, what I would highly recommend you do is I would highly recommend you clean this up a little bit before we try to do it. Our calculus is done. So we're going to look at this as 4x to the third times 5x plus 2 cubed plus 3 times 5 is 15 times x to the fourth. That's a 15x to the fourth times a 5x plus 2 quantity squared. Now you're going to be able to see this stuff earlier. What I want to do, if I want to write my answer as a product, I now want to factor my derivative. What are you talking about? Well, excuse me. I can see both terms have an x cubed in common, because that one's an x to the fourth, and each term has at least this quantity of 5x plus 2. It has at least 2 of them in common. So what I'm going to do is I'm going to say my y prime is, I'm going to factor out an x cubed times 5x plus 2 squared, And when I factor that out, when I factor my x cubed out of this first term, I have a 4 times, okay, notice there's a times, when I factor a 5x plus 2 squared out of a 5x plus 2 cubed, I'm left with a 5x plus 2. And then I have plus inside here. Well, I'm taking my x cubed out of my x to the 4th, so I have a 15x. And when I take a 5x plus 2 squared out of a 5x plus 2, well, they all come out. There's only a 1 left. And check out what happens. So I have y prime equals x cubed times 5x plus 2 quantity squared times, what is this side? What is this stuff in here? Because this is so small, I'm going to look at that as a 20x plus 8 plus 15x. Well, I got like terms here. That's going to give me 35x plus 8. And there I am, completely simplified and factored. Well, why is it important to see that? Well, hey, check it out. I can see I have flats when x equals 0. I can see I have flats when x equals negative 2/5. I can see I have a flat when x equals negative 8/35. So I can solve that for 0. If I would have expanded it all out in this step and collected my like terms, okay, I would have had something to the 9th power somewhere probably, or the 6th power in there, and I would have run into something I would not have been able to factor, and it would have been a pain in the butt. So we want to keep these little bad boys nice and tight and factored, okay? So what we're going to do when you're integrating the product rule with the chain rule, meaning when we have powers of big parentheses we're taking, right after we get done with our calculus right here, now we want to look for GCFs in here. We want to look for greatest common factors to pull out, okay? And I can see them way back here. It's going to be beneficial for you to put the two terms together like I did right here, seeing the 3 and the 5 and the x to the 4th. So then you can identify that both of those terms, that's the greatest common factor between the two of them. We're going to pull that out, and then we're going to simplify what is inside the last set of parentheses, okay? One last example I would give you, I would encourage you to try this one here quick before I do it. Remember, there's a u, there's a v. Remember, when I'm taking my product rule, it's the derivative of the first term times the second plus the derivative of the second times the first, okay? And that's all I did on the other side. So y prime equals the derivative of 3x squared. Well, that's 3x, or derivative of x cubed, excuse me, is 3x squared. Now that's going to be multiplied by this term, which is 3x minus 4 to the 4th, plus. Now I have to take the derivative of that, and that's a chain rule because that's something to the 4th power. Well, that's going to be 4 times 3x minus 4 something to the 3rd, times the derivative of my something there, times my first term, x cubed. And I recommend, okay, some people aren't going to do this, which is fine, but it's going to really help you not make mistakes, plus 4 times 3 times x cubed. Well, there I have 12x cubed times 3x minus 4 cubed. And what you're going to notice most of these times, okay, this big set of parentheses, this guy right here, both of my terms is going to have that whole parenthesis in common. And when it's the whole set of parentheses, we always want to factor out the lesser of the two powers, okay? And I also see I have a 3x squared in common here. So I'm going to say y prime equals, I'm going to pull out a 3x squared, and I'm going to pull out a quantity x, 3x minus 4 cubed. And notice I always separate these with different brackets. When I pull 3x squared out of 3x squared, that whole thing comes out. And when I pull that whole thing, or I pull 3 of those out, I still have a 3x minus 4 left inside there. Plus, when I pull a 3x to the 3rd out of here, well, hey, I'm just left with a 4 in there, aren't I? And if I pull a cubed out, that whole thing comes out. So this whole derivative now, just kind of, I can see that 4 goes out. So I really have 3x squared times 3x minus 4 cubed times 3x. and I could put these two guys together and call it y prime is going to be 9x to the third times 3x minus 4 cubed. Why would I want to go through all that pain and anguish from taking my derivative to simplify my first derivative? Well, the answer to that question is you're going to have to find the second derivative of it yet sooner or later anyways. And this is going to be a nightmare to find a second derivative of. This is going to be even harder because now I have two products in here. And most of the time, these are going to factor down to a single product. Most of the time, not all the time, okay? The last thing we're going to look at here is we are going to look at symbolic derivatives, okay? These are old AP questions. I can promise you you're going to have these on your test, on your AP test, and on your test on Wednesday for me this week. And what they're going to do is they're going to give us a table of values, okay? F and G. And obviously F and G are differentiable at certain points because they're giving me my derivative and they're giving me derivative values. So they're giving me my function of F at 0 is 1. The value of my function F at 1 is 3. So they're giving me values of my function F and G at 0 and 1. And they're also giving me values of F, of the derivative of F at 0 and 1 here and here, and G here and here, okay? So what we're going to do is we need to be able to come through and find symbolic derivatives. What the heck do you mean a symbolic derivative? Well, right here, what is 5 times f of x minus g of x? Well, they want to know what is the derivative of 5 times f of x minus g of x at x equals 1. So what I'm going to have to do is I got to say, well, my derivative of this is going to be 5 times f prime of x minus g prime of x, okay? So there I just found my derivative of my given function that was given to me symbolically, and I don't know what f and g are. I don't really care because they're giving me values. I know the derivative of f of x is f prime of x. Then what I got to do is I got to come back because they want to know what the value is at 1. So I'm going to come back here and I'm going to get rid of these x's. And I'm going to say, hey, I need to know what they are at 1. So from there, now I'm going to say I got my constant 5. That's going to get multiplied by f prime of 1. So I got to come here, f prime at 1. So I know f prime of 1 is negative 1/3. So that's going to be times negative 1/3 minus g prime of 1. So I come to my g prime column at 1. And I can see g prime of 1 is negative 8/3, and then I do my math. So this is going to give me negative 5/3 minus a negative is plus 8/3. Well, that gives me 3/3. Oh, the value is going to be 1, okay? And we have a couple more examples like these here. And it's the same exact table of values. However, now I need to find out what the heck is the derivative of f of g of x. Hey, look at that. It's not a product. It's not a quotient. It's a composition of functions. So my derivative of f of g of x is the derivative of the outside, leaving g of x in it, chain rule times g prime of x, okay? That is my symbolic chain rule of a composition function. Then I'm just going to come back and say, hey, they want to know what is the derivative of that composition at 0. So I'm just going to come back and I'm going to get rid of these x's here because those x's need to be replaced with 0. And what I'm going to do is now I have 2 stages to plug in here because this is going to be f prime of, well, what is g of 0? So now I got to find my functional value g at 0, okay, that's 1. So that's f prime of 1 times g prime of 0. So I'm coming to my derivative at 0. That's 1/3, 1/3. But now what's f prime of 1? So that's making me come to my f prime column at 1. Oh, that's negative 1/3. So that's going to be negative 1/3 times that 1/3. Well, that gives me negative 1/9. So f of g of x, the derivative of f of g of x evaluated when x is 0 is negative 1/9. Okay? And we're just going to do a couple more of these. They're all a little bit different. Okay? And you have a whole pile of these in your homework that you got to do. And what I got to do here is I got to look here at the next one and say, whoa, I got a little chain rule here. I need to find out what is the derivative of f times g cubed of x. Well, hey, I want to see this like this first, times my g of x is to the third because I have a composition function there, okay? So it's something g of x cubed, so something cubed. So the derivative of f of x is f prime of x times, what's the derivative? Ooh, hold on, Kruger, we have a whole product here. So I have a u times a v yet. Whoa, so the derivative of the first term is f prime of x. The derivative, or times the second term, which is g of x cubed, plus the derivative of the second term, well, that's 3, leaving g of x in it and calling it squared, times chain rule g prime of x, because that's inside, times the first term, f of x. Okay, so my calculus is done. Here's my derivative rule for that function laid out, okay, because it's a product of f and times another function of x, mixing a product rule with a chain rule. I'm going to come back, I'm going to grab that cute little eraser, then I'm going to get rid of every x in here, and I'm going to follow the order of operations after I plug them in. And this says we want it when x is 0, so I'm putting a 0 in for these x's here. And I'm just going to go to my chart. Well, f prime of 0 is 5 times, oh, what's g of 0? G of 0 is 1. Now we got to remember we're cubing that one, plus 3 times g of 0 again goes inside there. So I got to come to my g0. Well, that's going to be 1. Now that one's squared times g prime of 0. So now I got to come to my g prime at 0. That's times 1/3 times f of 0 yet. That's going to be f of 0 is 1. And then I'm going to say, well, 1 cubed is 1, so 5 times 1, that's 5, plus 1 squared is 2, so that's, or excuse me, 1 squared is 1 times 3, so that's 3 times 1/3 times 1. So this is really 5 plus, well, 3 times 1/3, well, that's 3/3, so that's 1. So this whole function evaluated it at 0 is going to be 6, okay? But what are they doing? They're testing, do you symbolically know how to take the derivative of a composition function and a product at the same time, symbolically come to a table of values where they didn't give you the function and they're just giving you functional values and derivative values at certain points, okay? Here's our last one that we're going to do. And then you're off and you can go do your homework, okay? So this last one, this is like an f of g of x, okay? I have a composition function here with all these parentheses, okay? So what are we going to do? Well, we're not going to punt. What we're going to do is, I'm going to get rid of that. We're going to take the derivative of the outermost function. So we're going to say f prime, and we're going to leave everything inside of that. And we're going to say times, now we're going to move to the inside function. Now we got to take the derivative of the inside function. Well, times, what's the derivative of x? 1 plus, what's the derivative of g of x? G prime of x, okay? And now I'm going to come back and I'm going to get rid of all my x's, and all my x's are going to be 0, okay? So I'm going to come back here, I'm going to come back here, and I'm going to come back here. And I need to put all kinds of, I need a 0 in there, I need a 0 in there, that was a 0. So I'm really looking at what is f prime of 0, g of 0, I got to come to my g of 0, hey, that's 1, so that's like a 0 plus 1 in there, times by 1 plus g prime of 0. So I got to go g prime 0, that's a third. That's going to be 1/3. And now I need to know this means f prime of 0 plus, so that's f prime of 1. So I got to go to my f prime at 1, that's negative a third. So that's going to be negative 1/3 times 1 plus 1/3. Well, that's 1 1/3, which is actually, because I got to multiply it times another fraction, we need to call it 4/3. And what's negative 1/3 times 4/3? Negative 4/9. And I just got to keep my symbolic derivatives all together through that whole thing. And that sums up the rest of our chain rule. You can finish up your homework tonight, guys. Tomorrow will be a full-on review day on the review assignment. I will have our meet open so you can pop in and ask questions. And those of you that are on 8As, you will be here to ask any questions. Have a good one. Talk to you tomorrow.